On est tous là. Ouais, super. Ah, ils vont peut-être faire une présentation avant on peut tester. Je vais brancher. Et s'ils nous cassent les couilles, on leur lancera leur truc. Et puis. Oh, il n'y a personne qui joue. Ah si, une personne. Youhou. Pap, pap, pap. Analysez maintenant, vas-y, analyse. Putain. Non, bah alors dans ce cas, on analyse pas. Non, 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 non. Il y a les deux là-bas, une autre qui arrive là. On veut juste tester rapidement. Est-ce que notre présentation marche? Ça devient pas mal. On va remettre la présentation là. Vous êtes un officiel de l'année ou un jury? Non, ah, Eric. Je me rappelle parce qu'on avait, on a eu pendant bah, un an. Un an, il y avait Eric qui était censé reprendre Pauline, qui ensuite s'est séparé. Et du coup, quand on nous a dit il y a Eric, on a fait le retour. Tout va bien. Voilà, je me rappelle du. On m'entend. En live. On m'entend en double. Ouais, il était bien sûr. C'est pas une slide ouverte qui est en train de jouer la vidéo du live. Ah, attends. Non. Non, non, mais non. Ah non, c'est nous. Avec genre 10 secondes de délai. Oui. Regarde. Vas-y, parle.
Oui, ça va, tu nous entends? Yeah.
Je peux pas faire.
Ah, mais ça vient de dire le 10 secondes de délai là.
Ah.
Attends.
Oui.
Ah, mais c'est eux qui sont allumés.
Ça va, tu m'entends?
Il n'y a pas un délai de sur le micro.
Mais je crois que ça retransmet le son de.
C'est le live. Mais oui, c'est le live. Il est où le live? Par contre, c'est pas un onglet. C'est pas petit.
C'est Joanne, c'est marqué juste avant pour rentrer, il y a les mots pour avoir.
Ok, mais on s'en fout que ça prenne toute la place.
Ah non, c'est pas Joanne, c'est qui le jeu? C'est le pitch.
Ouais, c'est le live.
Si, c'est Joanne.
Il y a une espèce de résonance.
Il y a une résonance.
En fait, on nous entend avec genre 20-25 secondes de délai.
Genre, si on parle là, après, notre son va revenir dans 10-20 secondes, ouais.
Attends, t'es allé trop vite. Non, j'ai regardé, moi j'ai vu c'était. Attends, d'abord on regarde tous les commentaires. Il y a un commentaire pour le voir. Ah, pour les minutes.
Je crois que ça a été réparé.
C'est qui fait ça?
C'est moi.
Ça va aller, c'est pas grave, c'est pas tout. Parce qu'on va pas pouvoir parce que. Non, c'est bon, c'est
Parce qu'on a en même temps, je peux pas plus.
Attends, oh! C'est vide.
Ouais, mais justement, moi, il y a comme ça.
Mais par contre, on va pas quand même pas tout. Il y a tout texte.
Ok.
Mais moi, ça m'arrange parce que je ne sais pas.
Est-ce que vous pouvez faire la présentation avant de passer, remettre le petit diapo qu'il y avait tout à l'heure?
Ah non, regardez,
Ah, vous avec le lien.
C'est le son de test.
Bien sûr, bien sûr.
Quoi?
Je vais pas vous vous pouvez mettre de
Pourquoi ça revient avec ça?
que je veux les voir, tu sais. Que vous mettez en lien genre, je parle de projet.
Qui c'est qui présente la team? C'est pas moi.
C'est Joanne.
En fait,
Il est en train de récupérer ton sac, c'est la non?
Un seul micro. Ouais, ça.
Vous le passez pendant la présentation, mais après, il faudra le passer.
Faut utiliser cela.
Ok. La slide d'après, on va voir.
Ouais.
Oui. Pourquoi il n'y a plus de rien à droite?
Normal, c'est pour les gens qui voient.
C'est nous les gens qui devons voir.
Ok, c'est bon.
Ça, je sais. T'inquiète, rien. Regarde-moi. Pierre.
Tu savais. Non, mais tiens, le stress, ça fait partie de ma vie. Je stresse depuis que je suis en troisième. Je fais de la psychologie.
Est-ce que c'est la vidéo? Normalement, il y a déjà du son là. Oui, voilà.
La façon de faire.
Non, ça va pas là.
Ça fait sur les autres. Pour le transfert des enfants.
Et si tu play juste la vidéo, ça marche?
Ok. C'est bon, c'est bon.
Non, non, normalement, il y a la vidéo dans la clé. Sauf si tu l'as pas fait.
Oui, on peut décaler, on peut balancer la vidéo à part.
Ouais. Bah, c'est ce qu'on avait dit avec.
Oui, tu la mets, tu la réduis et puis tu la fais pas.
C'est Altab, Altab, espace, Altab.
Je vais juste me connecter.
Bon. Oui. Oui. Oui, on ne fait pas la gueule quand on rentre au soir. Bah, on a un pro qu'on te donne. C'est que lui? Et pour poser aux questions.
Pour les questions, sinon c'est
Et nous, ce sera là pour les questions.
Non, mais c'est jamais.
Ok.
C'est là, on se rapproche.
1 minute. 45.
Est-ce qu'on est bon sur le reste? Genre, tout le monde est OK?
Non, ça c'est bon.
Non, mais ça c'est ce qu'ils veulent montrer avant qu'on y passe. Test. Ah, c'est ça. Je sais pas s'il y a tout le jury, mais juste avant qu'on présente et tout, vu que c'est retransmis en live, c'est mieux de poser les questions dans les micros, parce que sinon on vous entend pas dans le live, pour avoir regardé les lives d'avant. Donc voilà, c'était juste histoire de donner l'info.
On répond. Ça pour tout le monde?
Oui.
Ça marche. On dit pas du monde, donc on peut faire un peu.
C'est pour rappeler le jury, c'est pour les. Bah, il y a Vanessa Zé, on pourrait faire Vanessa Zé aussi. Ah, Vanessa Zé. Elle est où, Vanessa Zé? Comment? Elle est là. blind test. Sinon, on va chanter. Parce que je fais un 4 ans.
Non, c'est toi.
En général, quand on faire, on est là à attendre. N'hésitez pas.
Bien noté.
Bah, même les P3, si vous avez des questions sur la troisième année, allez-y.
Bien.
Non, bah, on met l'ambiance comme on peut. Hein. Pas me déconner, les petits points. Je me décale.
Bonjour à tous. Alors, merci d'être présents aujourd'hui pour l'après-midi de présentation des projets des troisième années de licence. Merci aux membres du jury d'être présents aujourd'hui. Alors, nous allons écouter 4 groupes de L3 cet après-midi. Chaque groupe a une demi-heure de présentation, donc entre 15 et 20 minutes de présentation et 10-15 minutes de questions. Je vais laisser Stéphane présenter les contraintes que nous avons demandées à nos étudiants cette année pour la conception de leurs jeux vidéo.
Bonjour à ceux à qui j'ai pas dit bonjour. Donc, comme je m'occupais avec Stéphane Froment du cours de gestion de projet en troisième année, et que ce cours sert en fait, de cadre dans lequel se déroule ce projet, je vais vous rappeler les contraintes. Je ne vais pas vous rappeler tout ce qu'on raconte dans le cours de gestion de projet parce que ça risquerait d'être assez ennuyeux. Non, je vais juste rappeler les contraintes auxquelles ils étaient soumis. Alors, ben, vous avez les principales qui sont là. C'est un jeu vidéo incroyable, produit par une équipe allant de 7 à 9 élèves. En fait, c'est pas tout à fait rempli. C'est un jeu de bac à sable. C'est sur une plateforme unique ou multiple, il n'y a pas de contrainte de ce côté-là, dans un environnement choisi simulé. Alors ça, c'est parce que il y a, comme c'est un cours de gestion de projet, il y a à examiner un contexte économique de production, ce qui veut dire que c'est évident que vous ne faites pas tout à fait la même chose quand vous êtes dans une boîte de 1500 personnes ou dans un studio à 3. Mais c'était à eux d'imaginer l'environnement dans lequel ils étaient. Vous avez à choisir un processus de développement, suivre ce processus. Alors, je ne rentre pas non plus dans ce détail, mais il y avait un processus de qualité logicielle avec des étapes à laquelle il fallait rendre les différents documents. Et puis aussi, il y a un cours qui s'appelle Le joueur et son marché, dans lequel on parle du suivi du joueur, des analytics et des instruments. Donc, on leur demandait bien entendu pas de faire le suivi des joueurs parce que il était peu probable qu'ils aient la population de 2500 joueurs à la fin du projet avec des analytics sur 6 mois. On leur demande simplement dans la présentation de réfléchir à quelle politique d'examen ils voudraient faire et comment ils instrumentent le code pour pouvoir avoir les données qui leur permettront de faire ce suivi des étudiants, des joueurs, excusez-moi. La suite, hein. C'est magique. Euh, le serial killer vient de frapper un grand coup. Ouais. Ouais. Ouais, mais je vais vous le faire en rythme. Bam, bam. C'est comme ça que. Alors, simplement parce que je ne vais pas connaître par cœur le deuxième slide. Voilà. Ça, je n'arriverai pas par cœur. Ils avaient autre chose, c'est qu'il fallait choisir deux contraintes qui étaient extraits d'un des cours qu'ils avaient. Donc, les contraintes sont là. Simulation, parce qu'il y a un cours de maths avec des équations différentielles. Donc, simulation d'un processus continu, du multijoueur en ligne avec la gestion des comptes. Il y a une autre contrainte qui est liée au cours de sécurité, qui est la sécurisation des comptes. On pouvait baser le gameplay sur de la reconnaissance d'image. Je crois que vous n'aurez pas ce cas-là. De l'animation de personnages humanoïdes 3D, ça par contre vous allez avoir. Donc la gestion d'une base de données temps réel type MMORPG, et développer un ensemble de shaders adaptés au projet. Vous allez voir, il y a plein de shaders. Voilà, et puis les points, en fait, ça apporte plus grand-chose, j'ai déjà tout raconté. Et donc, je m'arrête là. Il y avait un processus dans le temps qu'on n'a pas tout à fait suivi, pour diverses raisons, dans le détail desquelles je n'entrerai pas, et qui faisaient mais qu'ils ont dans l'ensemble, eux, séquencé. Et je m'arrête là. Et je voulais dire une dernière chose. On a dit il faut se servir du micro, ce que je ne faisais pas. Je pense aussi que c'est intéressant quand vous posez une question, vous rappeliez qui vous êtes, aussi pour les gens qui ne sont pas là et pour eux. Voilà. Et maintenant,
Attends, juste avant.
Je reviens un petit peu en arrière. Oui. Ah, on refait la compte. Ouais. Et repique sur la fenêtre à gauche. Et voilà.
Ouais.
Ouais, c'est voilà. Voilà.
Hello, everyone. Thank you for taking the time to listen to us. We are the Party Intruder team, and we want to tell you that you won an award, and you are invited to the Rose Lake camping. I hope you will enjoy your site and your vacation.
So, Party Intruder is a stealth action strategy game that places a player in an assassination sandbox. The player takes off on the role of a slasher villain who has targeted an isolated group of people who will seek to kill each of them as creatively as possible without alerting the police. When compared with our slasher-style competitors, our game draws its originality from the creativity of its assassination methods, which are similar to those of Hitman, but a little more daring. What makes our game different from Hitman, whose gameplay is very similar to ours, is the number of targets you have to kill. We are not playing an assassin, but a slasher villain. Instead of a few targets, you have to kill the whole map in an aesthetic and atmosphere that's more horror movie than James Bond. So for the teams, I'll try to be quick. I'm Joan, the project manager. Yeah. Then this is Dorian, a developer, Lilian, another developer, Corentin, the lead developer, the first Leo, our graph, then Emil, Picard, and SQE, and the other Leo, our game designer. For the constraint, to fit our constraint, a Party Intruder is a sandbox game. The player gets to run around in an open level where he can kill his victim however he wants. We try to use objects that are mostly physics-based, and some objects can interact together to create weird and illogical situations. We're not looking for realism, but for fun and creativity. As a constraint, we have the need to add tracking tools, make character animation, and develop a set of shadows, but we'll talk about this deeper later in the presentation.
So I will, sorry, I'll present the game design. First, let's take a look at the integrity of our game. The game is on PC. We use Unreal Engine to make it. Controls are like most FPS. We thought the game for keyboard and mouse, but it can be updated for controller. Player can use attack in melee, can throw weapons, can interact with things on the map, and drop what is carrying. So the camera is FPS. Our targets are casual gamers who are looking for a quick game, a fun game, aging from 18 to 40. It's a bit of a wide range. We're also looking for gamers who like the horror genre, mostly in movies. Our character is cliché, inspired by Leatherface or Jason. He's kind of a soulless, cold-blooded serial killer. He's called the Painkiller, actually. There's a bit of a story, but I won't go too deep into that. The objective is to be a fun game, nothing too serious, just a quick game to laugh a bit. Basically, this is our map. It's composed of a bunch of points of interest where you can find weapons, you can find AIs, you can find basically anything you can use on the map. And it's to help the player understand the map better and not be too lost. So there's a bunch of different places. There's also how you end the game. Basically, you can either get arrested by the police or escape. So you can use either a car or a boat to escape, which means you won't be arrested. You won't get a little page of journal. You can also get arrested by the police. You can take 2 shots and then you'll just end up dead. So there's no real victory in this game, just either you escape or you fail, because we want to let the player play how he wants and not define what's really victory in this game. So you have little journal pages, articles where you can have a little bit of a story and know how much people you killed, the weapons you used the most, and just a little bit of story about who you are and what happens after you escaped. And basically that's all.
Okay, so now we will dive a little bit in more technical terrain. So first of all, I will talk about the development management. So how we organize all of our code and our project. So we use the basic coding conventions for the naming system of our classes or variables. Same goes for the assets. We use the basic system used by Unreal Engine. So we have a prefix that represents the type of the asset. We also, very early in development, worked on a file tree structure in order to avoid issues related to redirectors when moving around, moving assets around in the project, which can be really problematic when using a versioning system.
Thank you, Emil. So I will dive a little bit deeper into the AIs, since they are a big part of the game and they are the main target that you have to kill or chase. We had with the game designers, and we tried to analyze how every behavior they could have, what they could do in every situation they would encounter. So they would be a bit more predictable, but still random, and would have like a bit of a human behavior. We didn't want it to go for a mass murder simulator, so the AI might feel a little bit clunky, but that's part of the design. A little bit. So we kind of expect what they are doing, but we don't for sure know what they will do. So you have to think about every corner cases when you design an AI. You have to think about every behavior and how they would interact through each others, and make, first of all, a theoretical model out of that. But then we have to implement all the AIs in the game. So as you can see, it's working beautifully, and they have a perfect pathfinding. But enough of the jokes. So we have to implement all the behaviors separately, like code all of them and program all of them, and then putting all the pieces together is very satisfying. Obviously, we encountered a lot of corner cases and weird scenarios where we would have to go back and tweak all the parameters. To make a convincing AIs, we have to do a lot of fine-tuning and adjust every parameters and the system necessitated a lot of iterations. AIs obviously aren't only behaviors, but also animation, sound, and so we have to put everything together to make convincing AIs. There is no magical value, so the main focus is the game feel and how the player feels chasing and killing and butchering our beautiful characters. Thank you. I will give the hand to Dorian for the analytics.
So for the analytics, we have several interesting metrics to analyze. The first one was the player position on the map. This information is crucial because it can influence other metrics. If we notice that weapons is used less frequently, it may not be because the weapon itself is unappealing, but perhaps the player hasn't seen the weapon in the game. This was the case for the frying pan. It was found in place where players don't often go, like the house. So to make it more popular, we will rotate the house so the door faces the player at the start of the game. Another type of metrics we collect is related to weapon, such as the number of kills made with a particular weapon and how often a weapon is picked in the game. With the data, we can determine which weapons are popular and which are not. And the reason can vary, such as weapon design or specific player preferences, or the weapon's location on the map, like I mentioned before. The final metrics we collect are related to the game session itself, such as the number of victims, their favorite weapon, and the time spent in the game. These metrics help us to understand how player plays the game. Like if the player is more aggressive than we intended, we will know it from the short game time and a high average of elimination. And if we want to change this, we can, for example, increase the NPC's ability to go on alert. To collect all these metrics, we use the Cognitive 3D plugin, which allows us to retrieve data in Unreal and display it as map or charts on the website. On this slide, there is a table with some metrics that we have identified as interesting. But despite these metrics, it was by observing and talking with the players that we obtain information that would have been difficult to determine without this. Two examples to demonstrate this is the player were not visualizing the weapon well enough, and they were trying to make the barrels explode. So we just had a shader to make the weapon more visible, and we had barrel explosions. And we are going to talk about art.
Thank you. So here is a concept art that we did early in development to help us fix the direction of the game. As you can see, it's very cartoonish. That's a choice that we made because we wanted to emphasize the non-serious tone of the game as opposed as what might be serious, hyper-realism or realism realism. One of our inspiration was were all the American comics, like for example, Joker comics. Here is how it looks in the game. Another reason for this choice of art style is how easy it was to make the assets, but I will let Emil explain how it works.
Okay, so basically we have 3 different steps to go from the concept art to the actual visual style of the game. The first one was how we prepared the assets. So along with the base color, we created a map of all the lines we wanted on our models. This map is found, this texture is in black and white, so we can use it as a mask to control the color inside the map of all the lines we wanted on our models. This map is found, this texture is okay. Anyway, so we can change and fully customize how our lines look inside the game. Next, we have a post-process effect that creates more lines, especially on the outside of the meshes. Basically, what we do is sample each pixel and compare it to its neighbors. If we see a big difference either in the angle or the distance of the pixel, we can identify the edges and trace the lines on it. Also, we can use the special parameter, the custom depth, to have lines of a different color, and we use it especially for all the interactable subjects that have a white outline, when all the other meshes have a black outline. Next, and finally, is the cell shading post-processing effect. So in this case, we check how light each pixel receives, and we sample it in 3 different tones, the light, the medium, and the dark ones. For each of these tones, we multiply by a flat and uniform color, giving us this amazing shading. Now we will talk about the second constraint, which is the animation.
Yeah, so as Emil just said, it was our second constraint, so it was a very important part of our project. So there is two types of animation. There is the player animation, which are viewed in first person, and there is the NPC animation, where you can see the full body of the mesh. So for the player, these animations are mainly used to handle weapons and to convey the gameplay of the game. The way we achieve this is using sockets, which enabled us to attach weapons and reuse animation. So we could have a lot of variety in the weapon arsenal. The other type of animation are NPCs. So we had to find a way to use different meshes with the same animation. So that way we could have different NPCs, which was very important as well for the variety of the game. And if you wanted to, we could have a lot of different NPCs. The animation in itself was a pipeline. Was a huge challenge. So animation are centralized around Blender. Why do I use the word centralized? Well, it's because animation done in Blender are incompatible with Unreal, so we had to use that add-on. But animation using from Mixamo, which we used also later in the project for the NPC, for example, aren't neither compatible with Blender nor Unreal. So we had to use a lot of add-ons and doing retargeting and whatnot. Another topic adjacent to animation was the use of fractal. It was very cheap to add and add a lot of flavor and silliness to the game. So we thought it was a nice touch. And also it helps sell the non-serious tone of the game quite well. Next, concerning the sound of the game, the audio, we didn't have much time to really develop it, but we primarily focused on two elements, which was the gameplay. We wanted to nail the feedbacks and core gameplay loop, so we put a lot of emphasis and effort in the gameplay audio. And game events as well, because at certain point of the game, there is events that the player should be let know of. Like for example, if the player has been noticed of witness committing a murder, or if an NPC is calling the police, or if the police are on their way. We did a bit of voiceover ambience and music, but it will be something we could develop in the future. And I will let Lilian for the management.
On a little less fun note, but still important, how we managed the work we had to do and the team. So for the project management, our workflow was inspired by Scrum, which was similar to the Agile one. Every week we had to meet on Discord and we share what we have done the last week, so we could focus on the next design element we wanted to add, or to make sure everyone know what to do and to ask questions if needed to the other teams. For the team management, all the management was made with the leads. So we had the game design lead, the game art lead, and the dev lead. They were making meetings to know what we wanted to do in priority in the project, and they were later dispatching it to all the team members, such as the devs and the other graphs. The lead will then put himself to works also, because we are still a small team, so they needed to work. For all tools, we mainly use Discord for all the reunions and to organize all our all the topics into different chats. We use Trello for the task management and to know what we wanted to do and how we want to manage what is coming and what we have to do. Mainly for the sharing of all the assets and the game files, we used Perforce, which is easier to use on Unreal Engine and the blueprints. And finally, we shared all the game assets and everything around the project for management on Google Drive, so it's easier for us to access it. We made a deliverable schedule, so we plan to do all the release and the first, the first game concept and prototype in early January, and obviously we followed that thoroughly and didn't make any mistake and weren't late. For the configuration management, so we use Perforce because it can automatically handle versioning for all the files and handle space management through a branch system, which gives the possibility to slice the development of multiple functionalities. And then those branches are then merged to the main one after reviewed and approved by the SQE and our lead dev. We also use, like I said, Drive and Discord The builds are made after every milestone validation by the SQE, and after we are sure that no conflict happened after the merge with the main branch. And for the configuration of all our visual resources, we design documents and management documents. So like I said, on Google Drive, each file is correctly ordered in a tree structures, and then they are archived when they are no longer up to date. So we can go back to the old version if we want to, or if we need to.
I'll make a bit of a retrospection. Firstly, we did hazard analysis. We chose to use a lot of C++ in Unreal, and we analyzed that as a big hazard, and we were right. We use Perforce, we use Unreal, and both those systems are a bit tricky to use, so they were also at risk. There was also the general organization. That was a big hazard because we didn't know how to work at 7. It's a big number. So to prevent it, as Lilian said, we did weekly meetings, we communicated a lot. And most problem came through. We had problem with C++ with the creation, the configuration of Perforce, and Unreal was capricious a lot. But still, we did our best, and there are a lot of things that we are proud of. We think the game is good. We enjoyed playing it, and we saw people enjoying it too, so we're happy with it. The player feels the power of fantasy. The A is not perfect, but good enough to challenge the player. The level design is okay too. It's kind of good. It has a lot of interest points, as Leo said. So for the weapon, the scenarios, we learned a lot. A lot. How to manage a big group, how to use Unreal a lot. We already did a bit of Unreal, but we learned more and more. And even the C++, which was a bit abandoned at the end of the project because it wasn't efficient enough. We did learn a lot about C++, and especially how to use it in Unreal, because it has a lot of bizarre working. But we did learn a lot. If we wanted to go further, there are a lot of things that we could do, add more functionalities, more way to kill, more NPC behaviors, a kill cam, achievements. That was in the backlog, but the time. And a lot of more assets like anyone else, more weapons, more details, more NPC models, and so on. But we didn't. Thanks a lot. If you want to ask a question, feel free. You can ask it in French or in English. We will answer you in French or in English, depending on you. It's okay.
Hello. I just wanted to know if you, by any chance, were inspired by games like Manhunt or Hitman.
We were heavily inspired by Hitman, as Leo said. Manhunt, a bit less, but I know a bit of the game, and I think it looks a bit like this. I don't really know the game. Anyone?
Yeah, the game is well known for being gruesome and being controversial. That was a very important aspect and question we had. So we really tried to emphasize the silliness of our game. So we didn't want to be too gruesome or violent, not too much in that direction. But yeah, it was an inspiration, maybe for a direction which we didn't want to go. But Hitman, sorry, very much for the possibility and variety of ways to kill your victims.
Okay, thank you.
Merci beaucoup pour la présentation. Vous parlez d'un add-on Blender et du coup je passe en anglais pour vous demander why.
So in fact, we're using two Blender add-ons, one for converting the Blender animation to Unreal and one for retargeting the Mixamo animation to Blender. So that's a good question. That's a point I talked to briefly about. So we are centralizing the animation in Blender because that's where we have our rig with all the controllers and the forward kinematic. And it was very important to us because we wanted to have the hand-on and be able to tweak things if necessary. So every animation are compatible in Blender, so we can tweak them and then export them later on. Well, another point that I haven't explained too much is that the FPS animation were all made by hand, but the NPC animation were made using Mixamo. So that's part of the pipeline.
Et merci beaucoup.
Hello, I'm Sophie from Ubisoft Lyon. I have a question for you. You were talking about test and data management. Where did you get your data for your tests? Is it your own work, your own playing session?
We play the game in the team, and we have some students who play it a little for earlier version.
Also, normally the game that you played could have take data, but the PC didn't have a Wi-Fi card, so we couldn't. But theoretically.
Okay, thanks.
Merci. I have a few questions. The first one is related to the previous one. Can you explain your test strategy? You made playtests, you told about playtests. Did you make computer testing, unitary integration? How did you manage the test? My first question. Second question, who was in charge of the quality management? Okay, you win. Oh, yes, the last question is related to analytics. I didn't, maybe I lost it, but I didn't see in your presentation some basic measurement like retention. How many players finished the game, or all the players finished the game? They were happy and things like that. And you did not explain exactly what you put in your game to make the measurement, your implementation strategy of Unreal tools for analytics.
So regarding the finishing the game or not, basically a game is very short, like usually between 5 and 10 minutes, and all the players that tested the game usually ended the game either by getting arrested by the cops or leaving early before getting arrested. So pretty much every player finishes the game. Sometimes we had some people that wanted to leave, but since we are the primary testers and also our colleagues in the class, everybody tested until the end. I don't have all the data for the test this morning, but I believe it should be something like it. No, I want to answer the second question for you.
Was killed 5 minutes after the beginning.
For what we do with analytics is that I don't present everything, but we got all this information like the game time or all the information we want to have.
Also, if you allow me, we added a lot of events inside of the games that send calls to Cognitive 3D, so we can track like the data that we want. Like whenever we pick up a weapon, we know which weapon was picked up when and where, and we have all that data on the website. I mean, we have the session, and we can know by event and by a timer when the weapon was picked, where the weapon was picked on the map, and stuff like that. So that allows us to later on compile all the data, and being able to do the shard that you saw to know if that weapon was picked more or less than the others. We also know like where the player was at which point of the session, so we can retrace the pathfinding by replaying the session later on. And we have a lot of sessions, like all the teams did sessions, and we had the analytics, also the other students. So we can analyze how a session went and where it went wrong, if it did.
Last point, your testing strategy.
So Leon spoke a bit too close to the mic. We did a lot of testing, but not like unitary tests, because how to present it? We finished the game really later on. So the final build was tomorrow, this morning. This morning at 2 a.m. So we did tests to ensure that the game wasn't breaking visually, like things we could see, could understand, and we didn't have the time to prevent the game from having mistakes. We just went on to have a game and then remove the mistakes. It would be a bad idea if we wanted to have the game debugged properly, but we wanted to have a game to play. So if there are bugs, there are bugs, and
Thank you.
Can I maybe add to that? To use some technical terms relating to testing and management, we mainly did integration testing per feature, because once a feature was released, everyone in the team was testing it, obviously, and also peer reviews. Even further, we could almost say extreme programming, because sometimes we were in Discord calls together and programming together. So that's part of our reviewing process. But no, we were not doing unit testing. In fact, it's not really natively handled by Unreal, so it would have been a bit tricky to pull together.
Thank you.
Question? Thank you. Le deuxième groupe, vous pouvez venir préparer. Après, parce que vous avez dit. Je parle en français. Oui, en fait, oui, moi aussi, mais non, c'est pas parce que c'est pas. Ouais. Partout.
Avant, ouais. Un peu tôt, Florent, un peu tôt.
Hello? C'est bon? Okay. Well, good afternoon, everyone, and welcome. Today we're going to present to you our game, Skybound Odyssey. We'll start off by having a look at the context in which we had to create our game, followed by the project management, and then an in-depth look at the game itself, after which we'll go into the analytics and finishing off with a post-mortem. The context. So as you all know, we had two imposed constraints. The first was to create a sandbox game, and then afterwards was also to integrate game analytics. On top of this, we had to choose two additional constraints. So the ones we chose were a shader and the animations of the 3D character.
So I will present you the team. Here is Arthur. He made a part of the procedural generation and all the animation of the character. Matthias, he made a lot of different things in the game, like some gameplay mechanics. Sebastian made the other parts of the procedural generation and the save of the world, and he helped us to prepare this in English. Daniel, he is a game and sound designer, and he integrates all the sound in the game. And Yadmin, he made all the 3D and the shader of the game, and he made the movement of the boat. Virgil, he is a QA engineer, and he made everything about the mob. And me, I'm the project manager, and I made the network and the save. For the planification, we start the base of the project in September. We set ourselves deadline, like for December and May, for the project check and risk analysis. And for the final rush, we made a bootcamp to finish the game.
For the software part, we used Unity as the game engine for the well-done and foundables documentation. We also used Blender for all the modelization and animation. And we used Git for versioning with GitHub and to use pull requests with merge conflict. At the beginning of the year, we did some risk analysis to be able to counter any potential problems. The main concerns were we wanted a procedural map, but what if we can't achieve it in time? The simple answer is we don't do general procedural generation. We also wanted to have some multiplayer gameplay, but what if the Cnam's Wi-Fi isn't strong enough, isn't fast enough? Posing those questions can seem trivial, but it's important to answer them in order to be able to counter any disasters from happening.
So now let's talk a little bit about the game. First of all, the pitch. Skybound Odyssey is an exploration and survival game set in a sky filled with floating islands. To navigate this world, players have a flying boat that is more than their base, it's their home. Exploration, gathering, and upgrading are the keywords of the adventure offered to players. So our main inspirations were games like Tears of the Kingdom, Worlds Adrift, and the other mod for Minecraft for the Sky Islands. We have also exploration with Minecraft and Subnautica, and the boat was heavily inspired in Raft. And when we thought about the game, we asked ourselves, what feeling do we want to give the player, which for us, it was the game design, and we wanted to build around it. So we wanted to build everything in the game around the feeling of freedom. For that, we chose these two main design pillars, which were exploration and resource management. First of all, the camera, we chose a first person, mainly to have to contemplate the environment. The character was a raven humanoid because birds remind us of the idea of freedom. And the controller, we chose mouse and keyboard. The character controller, we wanted to give the player the freedom of movement. Flying is the most noticeable form of freedom when we talk about movement. And that's what we wanted to give the player. The player has to feel that he can attain every part of the island. So we gave also the player a lot of stamina to move around the island. For the resource gathering and management in a sandbox game, resource management is generally a big part of the sandbox game, but it can cut the flow of the game. That's why we wanted to have resource gathering that was non-invasive, so we could pick up the items as we were walking by. And also, if it has to cut the flow of the game, at least it has to be fun. And for us, physics are pretty fun. So when we cut a tree, we wanted the tree to have a physical behavior. For the level design, it can be a little difficult to make level design in a procedurally generated level. So we thought about it more in environment design. We wanted to make the important things stand out and give the player the freedom to fly and go wherever he wants, but he can acknowledge where the important things are. That way we can guide the player in a seemingly limitless environment, but some limitations are needed. So we wanted not to give the player the ability to go from island to island without the boat.
Another big focus of the game is the boat, a base that you can upgrade by extending it and adding more elements. Fortnite was an inspiration for the system. A build is basically a graph and every node is a part of the boat, making it simpler to both network and save it. So the boats move depending on what the player placed on. For example, if the player uses 3 sail but none is well oriented, the boat will not move. And the player can rotate the boat by using the helm.
So for the narrative part of the game, the narrative design was with 2 main objectives. First of all, for the curiosity of the player, to push the player to want to know more about this world and then explore more about this world. And we also used it as limitations. As I said, we wanted things to stand out in the level. And with the use of this obelisk that stand out in the environment, we could make the player look and see where the important things are, and that will give the player upgrades and allow him to craft and build better tools and continue the game. For the sound design as well, there were 2 main aspects. So we had the music and the sound effects. The music, we wanted to have a light music, simple, that was only there to accompany the player in this experience, but it didn't have to take the main stage. And for the sound effects, we wanted to add a lot of little sound effects around the environment to make the environment feel alive, even without the player.
For the animation, we rigged, skinned, and animated the player character ourselves. The rig had to take into account the double-jointed legs of the player. To do that, it required multiple layers of bones and a little more complicated IK constraints, as you can see on the legs. So here are some animations, the emote and the running cycle that is sped up in Unity. And for the integration, because we had networked multiplayer, we had 2 versions of the player in FPS and in third person. So we had to integrate 2 animation controllers. This one is for the FPS. And we needed also to separate the higher part, the upper part and the bottom part of the third person character to allow for the players to emote while walking, etc.
So the starting point for any procedural generation is, of course, the noise. It's essentially what's going to determine the behavior and just the general shape of what we're going to generate. So for this, we decided to implement our own version of a 3-dimensional Perlin noise. Once we have our noise, we've then got to be able to create our mesh. For this, we decided to go with the marching cubes algorithm, which we implemented ourselves, and combined with the 3D Perlin noise, allows us to generate islands that have a lot of verticality and overhangs and almost cave-like structures. So as you can see, the result of both of these can be seen above with an example. And a really important factor was the implementation of both the Perlin noise and the marching cubes into Compute Shader, which essentially allowed us to execute the calculations of the triangles of the mesh on multiple of the GPU threads, allowing for a much faster and a much more performant generation than if we had used the CPU threads. And as well, we also had many different parameters for both the Perlin noise and the marching cubes, giving us a lot more control over the result and the islands that were generated.
So once the mesh is fully generated, we need to populate the island. To do so, we used Poisson disk sampling, an algorithm that randomly picks tightly packed points such that they maintain a minimum distance between them. This allowed us to put forests and with trees, with plants, bushes, and a lot of other mineral implementations, like the minerals that are on the bottom of the island. Those parameters are used through scriptable objects. We indicate at which height the elements can be placed, what slope the ground must be for it to be placed, and in what biome they are found. So as you can see, you have all the information for the biome, for example, the weights of the ores, because in each biome you have multiple chances to have more coal or more iron, depending on the biome, and also the mobs that spawn only on certain biomes. Once the island is generated, we need to populate the world. To do so, we separated the whole map into chunks. A chunk can have 1 or 2 islands, and they are separated by 500 meters, so that the player is forced to use the boat to navigate through them.
So after the decision was made that we would use procedural generation to create the game world, we also agreed on the necessity to allow multiple types of animals to live all across islands. The main objective was to suggest an alive space where animals would be existent with or without the player. Another decision was to allow those mobs to interact between each other, like emulating an ecosystem. To try to achieve this result, there were still 2 boundaries that could prevent us to populate the game world: performance and interaction. So we gathered 2 systems that would allow us to overcome those issues. First, the object pool. It's basically like a container which is responsible to spawn entities at the start of the game and store it deactivated. Whenever we need to use one object, it contains works the pool to return a free object. And when we don't use it anymore, we return it to the pool. In our case, it had to support one more behavior, network synchronization, because we needed that each player meet creators at the same place and time. The second system is like the state machine pattern, which allows to achieve a biological-like creatures behavior. It allows dynamic and continuous behaviors where each creatures know what to do in each situations, either to flee or chase the player, attack it, or maybe attack another creature. It resolves around a state manager that is responsible for running logic with distinct parts, enters, update, and exit states. When a condition is met, we exit the state and then enters a new state, and so the loop continues.
Once we have the islands and the mob, we need to make things, so a craft system seems necessary. We used a Minecraft-like system, so we have 9 slots in which you can deposit items. They are then processed by the crafting table to be able to find if there are any matching recipes and available recipes. However, some craft need other intermediaries craft, so we make a book available in-game in which you can search for items and use a recipe more easily. Now you can craft, but you still need to gather resources. For the less big object, we made some script to be able to pick them on the floor like pebbles. And for the more complex one, we made some other script to be able to break trees to collect wood. Once you have collect things, they go in your inventory. The inventory is pretty simple. It's just a bunch of slots in which you can deposit your items to be able to transport many things because the player needs many things. And I will get my mic 3 elements.
So we had 2 specific use cases for the shaders.
For the first, we use the vertex shader for the sail. By combining noise and masks, we can achieve the effect of the wind blowing and inflating the sail. Then we use the pixel shader to make the textures of the island. The upsides of that are that after making one shader for only one island, we could easily replace the textures and change their colors and tweak some parameters to create variations and use them for different biomes, as you can see here. For the game models, we use assets we found online for the vegetations and everything landscape related, but all the other assets were made using Blender, like the tools or all the ship's parts. We then used Substance Painter for the texturing. It's a great tool based on layers, and it makes the workflow way faster and easier. For example, we made a basewood material and then used it as a base on almost every part, so we could easily have a consistency between the objects.
So first of all, for the saving of our information, we use the JSON format. And the idea to the general structure of the save is if we have our parent object that we want to save, itself could contain a child object that we also want to save, which again could contain another object to save, and so on, creating a sort of save tree that then at a latter stage we can go through for the loading of our world.
For the network, we decided to use Unity's network system, netcode, with Unity Service Relay and Lobby, because it's a lot easier and faster than creating our own server. Also, I made a clear architecture that made developing with network easier. We set up the network handler with all the network variables, etc., using interface, so that even those who hadn't worked on the multiplayer could easily use it. For the UI, we made a sketch on Figma, and when everyone is okay with it, I implement it in Unity. For the UI structure, every element inherits from the same, and all take data in parameter. So they will update only if necessary, a bit like React for the web. And I use a lot Twin for the animation.
Now it's time for a less fun subject, but not the least, the analytics. For the metrics, we focused more on the early game, since it's a sandbox game, so player can do really anything and make some illogical behavior. And in the short term, playtest would only or mostly be in that part of the game. Following the scheme, we have the number of things crafted, when the player quits the first island, and so on. On the more classic side, we have the creation of the player, his connection, or the number of players in a room. We used event and initiated analytics because they are the most useful data in a sandbox context. Getting data in a frequency way could be too much, because since the map is procedural, the world can differ from one player to another, so analytics on that aren't very useful. With these metrics in place, over the last few days, we've been able to collect some data, not a lot, nothing either, but some, like you can see here. With the first playtest, we had seen that the majority of the players weren't able to quit the first island in a reasonable amount of time. So we adjusted the first tutorial to improve that point. We will look at the data from today's playtest to better improve the game.
So to conclude, what could we have done better? We could have done more meetings. We had the threads where lots of the team's members had lost motivation. But after we shared everything and our progress, the motivation went up. And what is to keep? We started the project by choosing our tools and setting up a Git repo and a Unity project. And we all assigned our tasks, very quickly by personal preferences and affinity. And that allowed us to begin the project knowing what we were working on. And so it was really useful when we were merging everything together at the end.
So finally, we'd like to have some special thanks to some people. First of all, Alice Alain, who created our poster, as well as did a few of the illustrations you could see on today's presentation. We'd like to thank Camille's family for providing us with a location for our bootcamp. And we'd like to thank Alice Kiel for helping us in setting up this presentation and the slides you could see today. Thank you for attention and thank you for listening. And if you have any questions, by all means, don't hesitate.
Hello, Marie from Ubisoft Bordeaux. What does multiplayer mode add to the game?
Hello. Yes. Well, we actually, let's say it, when we were thinking about that feeling of freedom and exploration, and we thought about the games that inspired us, whether it was the games that were single player or games like Minecraft, when we thought about it, we directly thought that it was way more fun to explore with other people. And the games that didn't have the multiplayer, we always thought that it would be fun to have multiplayer, like in Legend of Zelda: Tears of the Kingdom. And once we were playing with that idea and implementing it, it was really clear for us that it was the right choice. And everything was way, way, way more fun doing it with friends.
Hello? Yeah. Okay. You talked about data analytics and you said regarding procedural generation, you're not sure or you encounter some troubles. Why did you choose this constraint?
So as we said in the risk analysis, it was a big factor as it's quite a technical point. We weren't sure if we could achieve it in time. Thankfully, we did. But it was in our first ideas of the game, one of the first things that came to mind was we wanted procedural generation, not just for the added feature of different playabilities every time we load a new world, but also for the technical challenge to learn something new and I guess grow as developers.
And now
I just wanted to add that when we thought about that idea, every time that we thought about a new game feature, directly we thought, what is it bringing to the feeling of the game? And when we thought about procedural generation, we thought about the curiosity of what new can I find in a new island, and it just made sense to have this feature of every island is a new environment to explore.
And now the project is ended or you've presented it. What kind of data do you think you can track or could be useful for you to continue developing the game? Just by curiosity.
Yeah, as we said, since this game was in the idea, even if it isn't clear what a sandbox game is, the idea was to have a list limitless without any time of the game. And so our first concern was the player to learn in the first island and everything. And from that point forward, I think we would like to know maybe the players how much time they spend on islands to see if we can guide them a little bit better. But other than that, I think the idea of the game is that anyone can play it in their own way. If they like to gather resources and build, they can do it. And if they like to explore island to island and don't have that interested in building, they can do that too. So we thought a little bit about it, and we thought that everyone can find their own fun in that way.
Is this an infinite world, or there are limits to your procedural generation?
There is no limit to the world. The only limit is what you can see at one time. You only generate eight chunks around the chunk you're in. But other than that, you can go back to the chunks you already went, and the same islands will be there. Just with the save system, if you go too far and you save your game, it might take a lot of your space, but that's all.
Okay, thank you.
I have a question about performance. Were you able to do like general, like throughout your project, were you able to check for performance? And if so, how did you do it?
So we did check for performances, especially on the procedural generation. It was an important factor. And I guess the main thing we were looking at was we're using the Unity's profiler to check for drops in frames and all that stuff. But again, there was a lot of work done on the procedural generation side to make sure that it can happen quickly and without causing any freezes or too many freezes on the player's gameplay.
Okay, thank you.
About the procedural generation, did you manage to merge the mesh created by the compute shader algorithm, or is each one of the cubes a separate mesh?
So the islands we have our island, our large island, which is separated into smaller chunks by 10 by 10, which each have their own mesh, which kind of go together. But in terms of the compute shader, what it sends back is from the compute shader, we get an array of the triangles that we want to build in the mesh. And then on the CPU, we then build the mesh. Compute shader's there to calculate the triangles to the mesh, and then we build them. Because we did it like that because we needed to have collisions and interactions with the mesh, and that needed to be done through the CPU rather than the GPU.
Okay, thanks.
Hello. Did you think of adding the possibility to create or delete terrain like in Minecraft?
We did. That was the inspiration from No Man's Sky for the kind of digging and the building. We had thought of it. It was on our list of tasks, but just wasn't high enough in the priority list to be able to be done in time for today. But it's definitely something that if we continue, something that will be done something that will be added.
Okay, nice game.
Another question? It's okay. Thanks to the group 2. We can applaud them.
Excuse me, I have seen that there are some bugs in the questionnaire. For example, in the questionnaire, you must answer about the mathematical constraint. None of the students has chosen the mathematical constraint. And if you don't give the answer, you can't not save your questionnaire. So just say there is no mathematical constraint. you put a 0, which will have no effect on students because they have they have not chosen the mathematical constraint. But if you don't do that, you can't save your other choices.
No.
So hello everyone, we are the Group C and we are going to present our game, Escape Paradise Island. We will first talk about the game and its functionalities and the constraints imposed by the Cnam-Enjmin and with the development process. First of all, let me present ourselves. Tom Caudrier here, he made some shaders and was the gameplay developers from some of the features in the game. Benjamin Favreau was the chief project and helped a lot on the gameplay development and also had to take the hat of 3D, of to find 3D asset and make 2D assets. And Stanis Kapostad, the chief technical officer, who reviewed our code and helped on the development of the game. And myself, Titouan Bailly, who was the UI developer and gameplay developer for the game. Let me present to all of you a black screen. Yeah, okay, very good. So let me present to all of you Paradise Island. The island mysteriously woke up on, surrounded by water and without any memories. The only thing you're sure of is that you need to escape. Even if you could stay here and build yourself a nice little shelter, you're better off using these resources on a boat. But be careful, because if your boat is not good enough, you might wake up again on this cursed island. So on the island, there is multiple resources, and all of them will be useful to accomplish your goal. To collect them, sorry, you can eat them with your bare hands, but that will take a lot of time. So you do the smart thing and you build tools with some spare materials you find on the ground. Each tool will be more efficient depending on what you're eating. For an example, an axe will be way more useful on wood compared to a pickaxe. Once you gather enough resources, you head towards your crafting station. This is the place where you'll be able to create and upgrade tools. But most importantly, refine materials that will help you create different parts for your boats that will make your journey on sea longer. Like a paddle will make you go farther, thus further. Crafting will cost resources and will be directly picked from your inventory or around the table, like logs that can be upgraded to be more resilient. You stash those resources in your inventory. You have a very limited amount of spaces, forcing to organize yourself. Since you want to stay as long as possible, there's a lot of chances you'll be swarmed with resources and big tools that take a lot of room in your inventory. To help you manage that, you'll be able to craft chests and move them around to stash them.
So you're in that island, that's good, but you need to be able to build something to survive and also to expand what you can do on this island. So one of the main features of the game is a building system to be able to create some structures, some elements, and with the resources that we can gather around the island, and also to be able to do the main objective of the game. The main objective of the game, escaping the island. So the main objective is to build a boat with the building system using different resources and the resources that we can upgrade using our crafting tables, our different materials that we can gather around. About the constraints, one of the constraints that we choose for this project was an animating 3D humanoid character. We choose to have a first-person controller for our game, but we also wanted to make the first-person controller fully animated. So we used since we don't have any 3D modelers on our team, we use some model that we found around the internet, but it has some it didn't have some rigging. So we use Mixamo and other animation tools to automatically create some rigs so that we use to create our animations. Our character is controlled by a simple or artificial, it seems simple animator. It has not too much states, but each of the states are inside more complex. For example, the ideal to run states is multiple nested blend tree, so that can be controlled by multiple parameters like speed, side speeds, and so on. For the other constraint, we decided to implement a water shader, a toon-like water shader. So the idea was to be able to have a shader that can recognize objects that are inside. So with foam and the depth of water. So in our process of implementation, we first needed to find how deep was a certain terrain for our water shader. So the first idea was to take the camera depth buffer that Unity can give us natively. Then we decided to apply a color gradient to this depth to have a darker color at the bottom and a clearer color at the sides. Then with some noise and distortion, we have been able to implement waves. And finally, using foam and transparency and tweaking some values to have a clean animated effects for waves and foam.
So, to create our build system, we use the Unity physics engine. And to do so, we are using anchors, which are represented in blue there. Assuming we are holding the red object here, we are approaching the red object to the green object. Then we get the couple of anchors that are the closest to each other. Then we tell them to attach themselves. But before that, we align them and flip them around so they are facing each other. And then we create a fixed joint, which is provided by Unity to bind them together. Then there is the cell shading shader, which can, as we can see, provides brighter colors and sharper shadows from the Unity basic shading. To calculate how our shader will display shadows and light, we do this in 3 steps. So we get our exposure with the dot product, which is a vector thing, and the normal of the object, the normal on the object at each pixel. I'm sorry. Then we do some math to determine if it's this pixel is in shadow or in light. Then we apply textures and shadow to the object. So we get this result. In white, it's just a plain color, and in with the texture, it's with the texture. We thought of game analytics, but because we are only 4, we didn't have that much time to implement them. But we thought about 2 main objectives. Determine if our design is easy enough for the player to understand, and the balance of the scoring system. So we thought about the time for opening the inventory and the time for crafting an axe or pickaxe to determine if the crafting and inventory system and gallery system are easy enough. And we thought about the final bot score and the number of resources harvested, sorry, to get if our scoring is easy enough to be not frustrating. To organize our project, we use Notion as a project tracking tool. We use Unity, obviously, as our game engine. We used GitHub as our source control, and Discord as our communication platform.
Okay, so now let's talk about how we organize ourselves. So we split our year in a sprint that made us work for 2 weeks. So we started with meetings where we talk to decide what we're gonna do on the 2 weeks of development. Then we used to develop on the game what we have to do. Then come the review. We used to talk we made a meeting, and we test each other's feature with some planification, like what we want to test, what we test, what is the result, if there is a problem or not. That was our unit testing. And then we start a new sprint with a new meeting, and that's how our year come to an end. We organize our game development with a delimited scope because, as we will talk about that later, we were only 4, so we have to make a scope that was maybe, how can I say, little, maybe. And we have to iterate and add some tasks, some feature to make the game more complex. Like that, even if we don't have a lot of time, we have a game that we can iterate on it and add a lot of feature. Yep. So this is our risk analysis. As you can see in Salmon, it was the risk we identified at the beginning of the year. So we knew that on the 6 members, one of us were searching for a job, but she didn't find. So we were. She had to left the license. So we were only 5. Then we asked the bad time estimation that always happen, I think. So it's come with what I was saying before, like the sprint organization and the iterable scope. And then we have the 2 other who was the thing we didn't think that could happen, but it happened, unfortunately. We lost a second member due to some personal reasons. He can't have work on the project. So we at the end we were only 4, and that's why we had to do to adjust our scope a lot. And the last time was the time reduction because in fact we should have 1 week more to develop, but because some administration problem and a thing that is very unlucky, we needed to do this presentation 1 week before the true date, the release date. So we can't have imagine that will happen, but it happened. I mean, it's like that in a real production, so it's okay. So what do we want to do now with this game? We have a lot of ideas. We have a lot of things we want to do. And as you can see, we come from far. Like, for example, we want to upgrade this building system. Our goal was to let the player have freedom of building so he can build everything. And like we take for inspiration from Zelda, we want to improve the game, like for the feedbacks, the UI, like there is a lot of things to improve to make this game more enjoyable and to make the game like we imagined it in the beginning. For an example, we wanted to do when you escape with your boat, you can come back to your island and there is some things you built or you placed that will be destroyed because of time, etc. Like it was replayability. But that's something we keep in mind, and maybe we will go back to it since, as I'm going to say in the postmortem, there is some things that we did that were good and that would help us go back on this game again. For example, we had Stanis that makes sure that our code was clean and that it could work with all of us. Since he did that, if we want to go back on the game and go and develop, it will be possible. And it helped us a lot on this week since we had to put everything together and we had the chance to not have many problems. It was just finishing points and try to work with the situation we had. But we also made some mistakes, like we try to create the game around the constraints. We didn't think of an original game. We didn't try to think of that. We just tried to think a game that would check all the boxes for the constraint. And I think that was a bit of a mistake from our part. And we had small to no post-production, like we didn't write a proper game design. We didn't have a lot of things. We were not sure how to implement them. For example, the building system had to have a lot of retext. Same thing from the inventory. And I think if we would have talked about that early on, we would have more feature implemented today. But it's still good in the end. So thank you for listening. And if you have any questions.
Just by curiosity, what is the longest trip we can do in terms of kilometers and how to achieve it?
In reality, there is no limitation to that. Since you can build literally a boat as big as the island if you want to, theoretically. But if we would have the time, we would have had more boats parts, more buildable parts for the boats. So we would have changed the balance of the game so that it will be harder maybe to have a longer trip or things like that. And maybe even if you can reach civilization, reach the end of the game.
But with some tests and for today and the other tests that we done on our side, I think the best score we did was like 300 to 500 kilometers.
Thanks.
Vous pouvez aussi poser les questions en français si vous préférez.
Well, I love the building system that you had. And I think like with physics, it's so easy for it to break. So I wanted to ask, what was the biggest challenge in the building system?
Well, you said it. It was physics. At the beginning, it was kind of sloppy, and we had to adjust Unity's variables, like the time of the update of the physics and the number of iterations it had to do. And yeah, we had also, like you are seeing now, some collision problems. And we just made sure that the player didn't collide with the element that is holding. And there is like problem performance issues. At the beginning, if we had 2 logs on the scene, it was okay. We run like 30 FPS, but if we added 1 log, it dropped like to 2 FPSs. So it wasn't very good at the beginning. We tried to make it better, and I think we achieved it.
Je peux aller en français parce que j'adore le français. Déjà, félicitations pour votre jeu parce que c'est une prouesse d'avoir ça avec votre équipe. Et du coup, ma question est en lien. Comment vous avez réussi à rebondir en perdant 2 membres? Parce que, enfin, perso, je n'imagine pas rebondir après ça. Donc, vraiment, comment?
Merci. Oui, du coup, comme on l'a dit un peu plus tôt, en fait, quand on a voulu créer le jeu et quand on a cherché un scope, on s'est vraiment tourné un peu comme ceux qui étaient là l'année dernière, les P1 nous avaient montré avec Wordbird, sur un scope qui se basait essentiellement sur une mécanique et autour de laquelle on pouvait itérer un max. Du coup, au final, oui, on a dû bosser pour ceux qui n'étaient pas là quasiment, enfin, logiquement. Mais on s'en est pas si mal sorti parce que du coup notre scope était vraiment bien découpé. Il était vraiment modulable et c'est vraiment ce qui nous a aidé. Donc je pense qu'on a vraiment fait le bon choix. Et au final, même si du coup on avait pu être 7 comme prévu, ben on aurait juste fait un meilleur jeu, on va dire, dans la mesure où on n'aurait pas été perturbé parce qu'au final il y a toujours des choses à ajouter. Donc je pense que c'était l'idée de viser un scope qui était très modulaire.
Et puis, même si on avait perdu du monde, on a toujours fait en sorte de pouvoir se rattraper. Par exemple, on a perdu notre 3D modeleur, ben, on est allé sur l'asset store à la recherche d'assets qui pourraient nous correspondre. On a perdu, pareil pour l'animateur, on n'avait pas réellement d'expérience en animation. Ben, on a dû vite fait chercher des tutos, chercher comment est-ce qu'on intègre avec Mixamo et tout. Donc, c'était pas nécessairement évident, mais on a fini par être débrouillard et par réussir à présenter quelque chose.
Et je rajoute aussi qu'à chaque fois, on a eu le temps de voir venir la chose. Donc du coup, on a aussi pu se préparer en amont. C'est-à-dire que quand Aubrey a quitté la licence, par exemple, bah, on savait que c'était possible, donc on avait déjà préparé la chose. Donc ça nous a donné le temps, entre guillemets, pour pouvoir s'adapter.
Je tiens juste à rajouter qu'il y a quand même une chose importante. On a eu de la chance, tous les 4, de très bien s'entendre et d'être d'accord sur la majorité des points du projet, ce qui nous a quand même permis d'avoir vu qu'on s'entendait très bien, de faciliter les choses. S'il y avait eu des problèmes dans ce groupe-là de 4 qui restaient, je pense que le projet aurait eu une tête vraiment différente.
Merci la caféine, j'imagine aussi.
Pas d'autres questions? Bon, on peut applaudir le troisième groupe. Et accueillir le quatrième.
Pardon.
Ouais, alors non, c'est pas comme ça. Hello. So, hello and thank you all for being here. We're going to introduce you to the making of Norma 13, our Bachelor final project for the Cnam-Enjmin. We needed to create a game with a sandbox aspect and choose two constraints. Our team chose the shaders creation constraint and the 3D modeling and animation. It was developed by Yannis Saribo, 3D artist and VFX, Florent Bascoul, lead game design, Jordan Burnet, user interface and sound design, Victor de Senneville, producer, Paul Luneau as the lead programmer, Joris Pineda, open world game designer and level designer, and Elodie Prudent, narrative designer. So Neoma 13 places you in Neoma Celia. The city isn't surrounded by the sea anymore, but the sun still rises and shines every day. Idleness and petanque are the main activities here. You'll have to wander around the city and prove your worth to the master of the Boulodrome, also known as the viewport steward. When we first had the idea 2 years ago during summer break to make an arcade game about petanque, we quickly realized that going to the beach was funnier than being in front of a computer developing games. So we put the idea on a shelf, and when arrived the third bachelor year, we saw an opportunity to develop it and maybe make it bigger than the initial project. The result is a mix of a third-person exploration game and an arcade sport game, both casual enough to be played by the widest audience. The main unknown was how to render the essence of petanque while modernizing it to keep the player in a relaxed and fun flow. So we analyzed what was a petanque game, and it's essentially two things. It's aiming and hoping everything will be all right. So we designed a throw controller, allowing to choose the direction, height, and power for every shot. Using moving cursors, the player stops manually. The controls are not really precise on purpose, retrieving the necessary adjustments you need in the real-life petanque. What we wanted was a game fun to play for every kind of audience, so we gave you the choice to play a classical petanque game or a more arcade one. So usually, to give the game an arcade feel, you make the game pace faster and simplify the rules. But the petanque rules are simple enough, so we needed to create a little spicy touch. And therefore, we found two solutions: a special arena and new rules. We added changing rule bonuses, adding strategy, randomness, and a reason to be petty, which are actually the same ingredients constituting the essence of petanque. So the first bonus, make the launch ball count as 3 if she wins. The second one turns the ball into a bomb exploding on arrival. And the last one just reverses the rule, and the furthest ball are now the winner ones. You can now have fun and a lot of enemies. And about the arena, we just wondered, what is the most famous known game involving a ball and randomness? Pinball. So this philosophy of game design to encourage the player to choose whatever they want depending on their mood, as creating emerging gameplay, was also the center of the level design. So now let Joris tell you about this part.
Thank you. We wanted for the level design of Neomacelia to be fun to explore and current with the universe we wrote. So first, we gray blocked the level design of the city that allow us to quickly iterate and test the design to improve it. When we were satisfied with it, but thank you, we replaced the blocks with the 3D assets we had. There are a mix of an assets pack we found at the Unity asset store and homemade one like the bâtiments, the buildings, sorry. But we wanted to further improve our design with the help of game analytics. Game analytics in our project have two main goals. First, improving the level design, as I said, and secondly, refine the pétanque gameplay to have this arcade feeling we wanted. For the open world, sorry, for the open world part, we have a heat map of the player's position and the time spent in the open world to see which part is ignored and need more working on it, or which part is good. For the pétanque gameplay, we have several types of data that we monitor. We have the ball trajectory to see the strategy of the player and also adjust the physics of the pétanque to have this arcade feeling. We also have the number and type of bonuses taken by the player to balance them if needed and see each one to see if it's good. And finally, the duration of a game. Classically, a game of pétanque ends when 13 points is reached, but we weren't sure if it was not too slow for the arcade feeling we wanted, and we saw this morning that indeed it was a little slow. So yes, but we do not have time to do proper play testing, so it is all in the future. So next is Jordan for the sound design.
Thank you, Joris. So for the sound design, I wanted to be really on point with what is our game. So first, it's a simulation, an arcade game also, and a living open world. So for the sound design, we wanted something that really match with that. So we have three main goals: immersions, sense of realisms, and feedbacks. For a bit of technical part, we didn't use Fmod or Wise. For the sound, it's already put in Unity itself. So for the immersion, we created a radio to help the player have a feeling to not be alone and a feeling also of living open world.
Radio PM.
But also, it was important for us to give feedbacks. For the pétanque, for example, we tried to make a dynamic version of the music to help the player, for example, focus when it's time to concentrate on aiming, and also feeling when the game is almost on the end, to give also a feeling, a feedback feeling. For the FSFX part, we also did the same way. We wanted to give the player sense of confirmation of their action to be sure that they understand the world, they understand the mechanic, and focus on what is important. And for the immersion part, we also wanted to give a sense of realism about pétanque, especially for the ball, which have a specific behavior to give this feeling of not a golf ball, not a basketball, but really a good pétanque ball. And then for the UI, we created something that match also with sport games and urban graffiti style. For example, we have inspiration from Jet Set Radio because we wanted to have this kind of mix in the chart. So we designed everything around this idea. Because it was important for us to give visual coherence through the game and give enough, like with the SFX, give enough feedbacks for the player to focus on what is the point of the main game. Then I will give for the art to Yanis.
Thank you. So, like Florence said, our main constraint were the shaders and the animation. So for the look of the game, we took inspiration from games like Jet Set Radio, like Jordan said, Bomb Rush, Cyberpunk, or Over. For the general look of the building, we took inspiration from the Brutalist architecture. For the 3D modeling part, we use mostly Blender. And we choose to model to create low poly models for optimization, and with an average of 3,500 vertices. So all the characters in the game use the same base mesh, and the poses are built directly from that base mesh, which allowed us to keep the animation data from the base mesh to the closest. We created a different set of clothes to give different shape to our characters, which allowed us to have a modular character that we could use to populate the city. For the animation, we used the Mixamo rig and the Mixamo control rig, which allows us to create animation easier and have access to the whole Mixamo library. For the shading part, we used a shader graph and a little bit of HLSL script. For the look of the characters, we created a cell shading shader. Without getting into the specifics, what it basically does is that it recalculates the light scatter on the surface of the mesh. And here you can see another shader we developed. We use that shader to load the level when the match begins. So it's composed of two parts. The first one is loading the topology of the mesh with that blue grid. And the second one is loading the real texture of the mesh, of the models. We chose to display the level like that to emphasize the fact that every pétanque match is occurring in the virtual reality settings. So that's it. Here you can see other shaders we developed for the game, like the hologram shaders, various dissolve shaders, the water, and the sand. We also developed some VFX and particles for the game that you can see while playing the game, like the explosion, the bump effect, and the dust effect. And with that, I'm going to leave the second part for the programming part.
Yay! Programming, fun parts. So as Florence said, the game is separated in several game phases with different controls, scenes, and gameplay. And those are really different. So it was important for us to separate as much as possible the different parts of the code and have a minimum amount of interface point between those. That way, it allowed us to be able to work on them simultaneously and decrease the number of bugs that could occur. For example, we set up a game manager responsible for several sub-game managers. Each sub-game manager is responsible for one part of the game, like the exploration, the dialogue, or the pétanque. And only one of the sub-game manager is updated at a time. That way, it's really unlikely that the exploration logic will ever interfere with, for example, the pétanque one. and vice versa. And we tried to keep this philosophy across all the code base using similar state machine-like logic, especially in the pétanque. And speaking of that, let's quickly dive into the pétanque shoot. So the pétanque in itself is heavily physics-based, but we wanted to be able to control a bit better the trajectory of the ball without using a custom physics engine. So we ended up using Bezier curves for the first part of the shoot, while the ball is in the air, and let the built-in Unity physics engine handle the rest while the ball rolls and bumps around. It allowed us to make an AI that can accurately shoot at moving targets without too much troubles and have good opponents. Those who tried this morning could conquer or not. Then, to ensure the consistency between the code produced by each one of us, one of the third thing we did was to write a code norms document. It includes naming conventions, good habits for code reading, optimization, or scalability. And to help us, especially those who are not used to these conventions, to apply all the conventions, we set up an editor config file, allowing our code editors, like Visual Studio, to highlight the part of the codes that do not respect them, like you can see on the second screenshot. And then, yeah, I let Victor handle the rest.
Thank you, Paul. Hello, everyone. I'm Victor, and I was in charge of the project management. So this year's project is bigger than other years. It's a bigger project, it's a bigger team, it's a bigger scope, and it's bigger expectation for us. But weirdly enough, it's the project we all felt like the most accomplished. The why? So the answer is quite simple, yet effective. It's the experience. Managing video game has a lot to do with risk management. What you see here is a part of the list of risks we established based on our experience in other projects. For the sake of the presentation, I'm not going to detail each and every line. Instead, let's see where's the experience talk and how it helped us tackle those risks, certainly not perfectly, but better. First of all, we all knew from previous experience we were going to need communication and organization. In this regard, we set up weekly meeting, produce documentation, we had a software support with Notion for task and bug tracking, and finally, we set up a workflow that allows easy iteration along with frequent tests and code review thanks to a pull request system. I'm not going to expand too much on those subjects. Even if those tools were necessary for a good production, we also knew that it wouldn't be enough. Wouldn't be enough because of the reality of the production. On this production, we were working remotely, working 1 day a week, not every week. We had to take in account professional and personal lives and deal with some gray areas in the planning. So, to overcome those risks and unexpected events, we did a way better preparation at the project kickoff. We put the pre-production time to good use. We use it for research to be sure of the task time and weight of the different parts. Also, we decided to split the role by following each team member's preferred skills, but also by avoiding multitasking as much as possible. Basically, we abandoned the idea that goes by everyone has to program. Instead, we evaluated our strengths and then tried to shape the initial idea of the project to respond to these. For example, we knew that we wouldn't be a lot of full-time programmers in this project, so we lightened a bit the third-person controller in exploration mode compared to what was initially expected. We then adapted the game and level design of the exploration to be more in adequation with that type of controller. Moreover, most of the time, things don't go the ideal way during the production. Nonetheless, to risk up in a more efficient and less frustrating way, we try to think from the beginning about backup plans and features we knew could be dangerous in terms of time loss. In conclusion, It's important to point out the fact that all of the managing tools I listed before were not necessarily successfully implemented or have worked as intended. There is still a lot to be learned, but a lot of the problems we encountered on this year's project were also naturally overcome by the experience accumulated by each individual over the years. Thank you. I leave you with that.
Waouh, c'était une super présentation tout le monde, et en plus en anglais, c'était incroyable. Merci à tous de votre attention, et on se retrouve tout de suite après le jingle pour les questions des auditeurs.
Radio BM.
Des questions?
Hello. So I wanted to ask, why did you choose not to use neither Fmod or Wise for the sound design?
Okay. Actually, it's not something I will say you should do it. But for my part, especially because I do sound design, I work on a DAW, digital audio workstation, and I can produce my sound exactly how I want. So using Fmod or Wise would have had software between already two software of producing. And because I'm also a programmer, I can do both what Fmod or Wise do, which is shaping the sound and using in one way. But I already produced that on my DAW and implemented that in code. So to me, it was an important aspect of time management.
Hello. I'm curious about the name of the game. What is the meaning?
Hello. The game came like I put a lot of thought about. No. I just had it with my coffee or in the shower. I don't remember, but it was a flash, and basically it's just we knew it was in a futuristic city, futuristic Marseille. So Mars, Neo Mars for new, and 13 because Les Bouches-du-Rhône, and also a game pétanque is won with 13 points.
Non, est-ce que vous pensez continuer à taffer sur le projet un moment, un jour?
Perso, je suis méga chaud, mais c'est uniquement perso, je laisse les autres répondre.
Le master, hein.
Pardon. Oui, je pense que moi aussi, par exemple, je suis chaud, mais je sais très bien que je dis ça tout le temps et que ça avance pas. Donc, je vais appliquer un principe de réalisme et dire que non. Voilà.
Mais par contre, c'est vrai qu'on a plein d'idées en fait qu'on n'a pas implémentées forcément dans cette version parce qu'on s'est concentré sur une vertical slice pour aujourd'hui. Mais par exemple, pour le level design, on avait prévu de faire 2 autres zones qui étaient centrées sur d'autres mécaniques de déplacement qu'on débloquait après avoir battu les boss. Donc comme un slide par exemple, et chaque zone aura eu son clan différent. Là par exemple, on va affronter le clan du cerf, mais voilà, il y aura eu d'autres animaux comme ça et d'autres mécaniques. Voilà.
Et ça me permet de relier ça au management de projet. Allez. C'est vrai que du coup, comme on avait pris le temps de la pré-production et que Paul est un splendide programmeur, on a des systèmes qui sont très robustes et très scalables. Donc, en fait, maintenant, c'est quasiment que de l'intégration. Donc, par exemple, si le level design doit s'incrémenter, et on n'a quasiment plus besoin de programmer. Voilà. Donc, c'est super.
Sachant que pour que Joris s'arrête de faire du level design, il a fallu l'enchaîner en radiateur, sinon il continue à nous faire Marseille en taille réelle, échelle 1-1.
D'ailleurs, n'hésitez pas à rejouer au jeu sur itch.io pour explorer tous les petits secrets. Il y a plein de petits trucs easter eggs sur la map.
Ouais, moi j'ai juste un truc à dire, c'est pas vraiment une question, mais franchement, c'est juste pour dire bravo parce que le jeu est méga polish, le son est top, les FX sont trop stylés, donc bah, juste bravo à vous, même la presse était cool, donc bravo.
En vrai, bravo à tout le monde, hein. Tout le monde a fait un fantastique job cette année, hein.
Une petite dernière question, peut-être un peu décalée du projet, mais juste pour savoir, les musiques du jeu étaient vraiment très cool. Est-ce qu'il y a un monde où elles sont disponibles quelque part ou...
Oui, je les mettrai en ligne. Normalement, ce sera sur Spotify ou votre truc de streaming préféré.
Ok, t'as pas, merci.
Il y a d'autres questions? Bon, on peut applaudir le dernier groupe. Merci à tous d'avoir participé à cet après-midi de soutenance. Merci encore au jury d'avoir donné votre temps pour évaluer les élèves de troisième année. Et merci à tous les étudiants d'avoir participé également, d'avoir posé vos questions. On vous souhaite une bonne fin d'année. Il vous reste encore des cours à terminer. On compte sur vous. Moi, je parle de choses qui fâchent. Est-ce que...
Et merci à Audrey, Pascal et Martine qui ont pu organiser tout ça. Un grand merci à vous trois.
Allez.
Eric à la régie aussi.
Ah oui, oui. Et merci à Eric, à la régie, et à la technique.